All right, I've been told that I need a mic, so let's see how this works. Can you hear me in the back okay? Doesn't sound that much different to me, but okay. So I didn't get a lot of questions, so I'm assuming everyone's either too polite or a lot of people raised their hands that you have experience with ggplot2, so nothing new so far, maybe, on everyone. Hopefully we'll start getting a little more advanced, and even if you've experienced ggplot2 before, there's be some new things. I'm going to start with, in all of the examples we've used in the exercise and I showed you, I started with all the information like the data and the aesthetic mappings in ggplot, right, in the ggplot function. And why can you do that? How does the layer know what the data and what the aesthetic mappings that you're applying are? And the way that it knows is that layers inherit the data and aesthetics. And that's a really important concept that I think a lot of people miss in ggplot. And it's important partly because what if you want different aesthetics in different layers? And Hadley made this package very flexible in this sense. You can actually take out all of the aesthetics. So here I've taken it out of ggplot and I put them all into the layer itself. And so these two pieces of code, which you've seen before, here is the first bit that we talked about originally, and here I've taken the AES and I put it all down directly in the layer. Those two are equivalent. They're exactly the same. In fact, you can even split apart the AES argument, depending on how much flexibility you need. And so let's see another example. This, here I've taken AES, I've left the X and Y, so all my layers inherit X and Y, and they inherit the data as well, but I'm applying the color equals sex piece. I'm distinguishing based on that variable only to that one layer. And so if you had multiple layers, you can apply different kinds of aesthetics to different kinds of layers. And not only are the aesthetics sort of flexible in where you put them and how inheritance works, but you can actually take the data argument completely out and put that right into the layer itself. And that makes it very flexible in how you set up your plot. And I'm gonna point out, and I hope you pay attention to this one, because this is a huge gotcha in ggplot from my perspective. You'll note here, I haven't named the argument. So those of you, I'm assuming that people in the audience are familiar, at least basically, with R. And so you can sort of name or not name R arguments depending on if you have the right order. If you have things in order, you don't have to name them. And so the first argument in ggplot is the data, and so you don't have to name it. You don't have to have data equals. But in the layers, this is not okay. So here I don't have data equals, here I don't have data equals. This, you get an error. And that's because the first argument to this layer is not data. So you have to have data equals, and if you think you're going to forget that, I would say use data equals 100% of the time until you sort of remember this and get comfortable with it. And in fact, a note to Hadley that the warning that you get when you do this is not self-explanatory. It's pretty confusing. I forget what it is exactly. Maybe someone, when they hit it, can remind me of it, but it's definitely not clear. So you need data equals when it's in the layer, and I recommend you use data equals always, at least at the beginning. So the question is, why might it be useful to include data in the layers themselves rather than in the ggplot object? And the answer is, of course, if you want to use different layers, different data sets in different layers. And I'm going to show you a baby example here, an uninteresting example, but one that I hope is easy to follow. Here's my exciting data set. It's my data set number 1, where I have A and B, and they're each 1 to 10. And then I'm going to plot it. So here, I'm plotting it with that here, AES in the ggplot object, and then the layer doesn't have any of the aesthetics mapping, right? And then I'm going to create a data set number 2, another exciting data set. And here, again, I'm plotting it by keeping the data and the aesthetic mapping in the ggplot object. But in that case, of course, you're inheriting. And so you can't actually use both of those data sets if you use this strategy with data in the ggplot object. So if you want to split it apart and use different data for different layers, you would pull those out and take them out of ggplot and put them directly into your layers. And here's what that particular code would look like. So here, ggplot is completely empty, but it starts out and creates that ggplot object, and then we've got layers. We've got genome point, and here, notice I have data equals. Here's one of the data sets. Here I've got data equals. Here's the other data set. AES in both cases are in the layers, and I can put them on top of each other, right? And ggplot is smart enough to know sort of how to alter those axes so that they both fit in there. And I am noticing that my plots in this case are getting cut off, and so at the next break I'm going to make it a little bit wider there so it doesn't happen. And then let's say, for example, so you've got two data sets here, you've got two layers, they're each using different data. Let's say you want to add one more layer with one of those data sets. Let's say you want to put a line through the blue. Can you envision sort of how you might do it? So instead of genome point, you would use genome line, and then within that layer you'd set the data set that you want to use. And so here's how that code looks. So here all up to here was from the previous slide, and then I'm adding one more layer. Genome line, remember, data equals, it should be right there, equals dat1. Make sense? So if you want to have different data or different aesthetics in the layers, you can pull it apart in any way that you see fit, any way that you need. So far, the only example of using aesthetic mapping beyond X and Y and color that I've showed you, those are the only three that I've showed you. But there are a lot more ways to sort of mix and match your aesthetic mappings. And the most useful, I think, are labels and size and groups. And I'll show you each a small example of each really quickly. I'm going to start with labels. So instead of color equals something in AES, I'm going to have label equals, size equals, group equals. So here's the label equals. Pretty nice plot. You can see in this example you wouldn't probably want to do this, but you can also see how powerful it could be if you have a smaller data set or some other sort of setting that you wanted to do it in. And super easy. Label equals sex. And you can mix and match as well. You could have color equals in that same aesthetic mapping, and it will color code those labels and make an even nicer plot. How about size? So here we've got size equals age, and then ggplot automatically for you adds the legend, sure. Yes. You mean, can you take these aesthetics and put it right in here? Yes. Yeah, you totally can. And in this case, you can barely see the difference between those little circles. They're a little too similar, I think. The default is a little too similar. If you wanted to actually change the sizes, you could just use a scale and alter the circle size, make that bigger circle even bigger. And then finally, the one I want to show you is groups. Now, groups is almost identical to color, almost identical. But let's imagine, and I'm actually going to show you an example here. Let's imagine you have a data set where you followed thousands of boys through time, and you've measured their height, and you want to create a plot where each line is a trajectory for an individual boy, but you've got thousands. You're not going to have an individual color for each boy, and you certainly don't want a legend with thousands, right? So that's where group comes in handy if you're doing some sort of longitudinal analysis and you want to do an individual trajectory but no colors. And so to use that, it's group equals within aesthetic mapping, and it looks something like this. Okay, a very powerful aspect of ggplot2. And in fact, does anyone do any spatial analysis or mapping in ggplot2? Only a couple. Okay. Well, that's how you keep track of what coordinates are part of, let's say, the same county. You use group equals. And just to give you a sense of the difference between colors, so let's say you ignored group equals in the particular example I just showed you. So we had individual trajectories. What would the plot look like if you actually dropped group equals? It would take every single observation, string it together in a funny little way, and create this. And what about if instead of group equals, you had color equals? And you imagine what that would look like this. So in this case, it's not so bad. We only have, I did a subset, and it's only, 20 boys or something. But you can imagine if you have thousands, it's not going to work out for you. So in all of the examples that we've done so far, we have started with ggplot, and ggplot will execute as soon as you're done. As soon as you run the code, it will open that ggplot. But there's a nice aspect of ggplot that allows you to save your plot as well. So here is the code that we've talked about before. ggplot, you run that, it opens, you've done that as part of the exercise. But you can save that ggplot as an object. So let me show you what that looks like here. This is an R object, P, and I'm running ggplot, creating that object, and then when you're ready, you execute P, and it pops up a ggplot. Now, this particular example is not that useful, but in Shiny, for example, I have a relatively big application I created for the World Health Organization, and there are situations where I want to start with a certain plot, but I want to keep adding to it through time. So I create a plot object, and I keep going through it through time, and keep adding. So here, you might set up your plot object, and depending on what a user selects, let's say in a Shiny application, you'd actually add that extra piece. Here I'm adding an extra piece. And in this particular instance, is this saving a new object called P, or is this executing the code and creating a plot? It's executing the code and creating a plot, right? But I could resave P as this plus this and keep going, and that's what I do in my sort of bigger applications. And it's a very useful feature of ggplot2. So let's get to the most powerful piece of ggplot, in my opinion, and that's faceting. So faceting is creating multi-panel plots and is your savior as a data scientist. It makes creating multi-panel plots so much easier. And there are two different kinds of faceting in ggplot. One is called facet grid, and one is called facet wrap. And how many, without any further, me going any further, how many of you think you know the difference between those two right off the bat? A couple. And how many of you use faceting in ggplot? Yeah, so yeah, not many people know the difference. And in most cases, actually, it doesn't really matter that much. But in a few cases, it will. So we've got facet grid, which is a two-dimensional grid. So if you want to have a variable of rows, a variable of columns, variable of rows, you can do that with facet grid. And wrap is more like a ribbon. So if you have a variable and you just want to sort of string it together in a ribbon fashion, that's where facet wrap comes in handy. So let's take a look at the syntax. So with facet grid, the syntax is your plot, so here's your plot, plus, just like you're adding a layer, facet grid, and then you give it a row variable, tilde, column variable. Now if you don't want either a row or a column, you can use just a period. So it looks like this, facet grid, and then no row but only column. So let's see an example of this particular one. I'm going to take that sex variable and I'm going to create it as columns. And it looks like this. And so here we've got facet grid, period, tilde, and then your variable. Okay, makes sense? And let's flip it around. Let's say we want that variable as the rows instead of the columns. So I'm going to have you look at this syntax, and how would you change this syntax? Right? You'd move it over, put the period on the other side. Like that. Pretty nice. And then where facet grid really comes in handy. In this particular instance, I probably would just use facet wrap in those previous instances, but where it really comes in handy if you want to use a two-dimensional grid. And so let's add one more variable. And let's have one variable as the columns, one variable as the rows, and that's where facet grid really comes in handy. So looks like that. So here's status. Sorry, but they don't have good names. But 1, 2, 3, and then female and male. So a really nice way to quickly take a look at your data in a multi-panel way. Now the alternative, and the one that I sort of default to in most cases, it requires less thinking, I guess, because it's just a ribbon. It just puts it in any order that you want, or any order that it wants, is facet wrap. And so the syntax for facet wrap, almost identical. You just add plus, like you would a layer, and then it's facet wrap, and then tilde wrap variable. Right? There's nothing before that tilde. Unlike facet grid, there's nothing before that tilde. And if you want, in the unusual circumstance that you want to sort of concatenate two variables, let's say you've got an age variable, I'm going to show you that in a second. It's got 5 categories, and you've got the sex variable. You can actually string them together, concatenating, and put them all together, and I'll show you an example, and then you can have var1 plus var2, but still nothing before the tilde in facet wrap. So here I'm going to show you how I cut my variable, my age variable. If you're familiar with R, this should be straightforward. I'm cutting it up into 4 categories so I can give you a better example. And then I'm going to use this age cut as my facet wrap. So there we go, facet wrap, tilde, age cat. And in the unusual circumstance where you want to sort of concatenate together different variables, you can do that too. So here, facet wrap based on 2 variables, and you can add them together. And that's a quick way. I don't like this as much as a facet grid. So if I have 2 variables, I'll generally use facet grid. All right. So we're on to the rest of the exercise, 8 through the end. Any questions before I go ahead? Don't be shy. No. All right. So move forward with the end of exercise 1. That lets people get away, though.
What's that?
It lets people escape.
Yeah. There in the UI, with the comments, I mean, if you just think of them as their function, right? So they're going to that's all. So they're separated by function.
Yeah, so RStudio stack there's no real way to do that first paragraph. It's just sort of like a So then the other question I have RStudio, like, it's not the but it is running R session visualization. And so what happens is if every time you run through that loop, your packages keeps getting if I well, I actually think okay.
So it sounds like you're saying
I'm not sure that I'm not sure I'm missing it.
the other thing you can do is you kind of like
Welcome back. I'm expecting everyone's going to get started on exercise 2. Remember, you open it with exercise and then the number 2. And just questions 1 to 7 focused on the user interface. Yeah. That was one of the few that didn't look so bootstrappy.
Yeah.
So I'm not gonna give you any more time, but just for future reference, how many people wish they had 5 more minutes? So actually, that's most people. So what I'll do is we'll go through the server piece, and then I'll sort of give 5 more minutes to complete the UI piece of the exercise when we get to the exercise, the server piece of the exercise. Okay. So when you run a function in Shiny, many of these functions like basic page or fluid page, this was question number 1, what happens? Yeah, it just gets compiled to HTML code, right? So that's basically what Shiny is doing in a big way. It's the UI anyway. Those functions are basically just taking bootstrap code essentially and converting your R code to HTML. So we talked about the UI, and now we're ready to get into the fun. I'm not promising fun. It's pretty challenging material, the server stuff. Hold on a second. Okay. And in terms of the topics, so here's what I'm going to cover. I'm going to talk about reactive values, and that's a sort of new concept for those of you with R programming experience. It's a very new concept. We're going to talk about the observers that are functions designed to listen to and react to reactive values. And then at the end, I'm going to talk about how you can generate text and tables and plots using sort of a trigger of those reactive values. And I'm going to start here just by defining what I mean by a reactive value. So I'm going to go back to some code that you've seen before, kind of. Here in the fluid page, I'm adding a widget. It's a text widget, and my question for you is, what is the ID of this text box? Right, my text box. So I haven't actually named this argument. I'm not calling it input ID equals, but I could if I wanted to, because it's the first argument, and the first argument is the unique ID, and this unique ID is what you can access within the server if you want to know, in this particular case, what the user has typed in. So that ID is extremely important. And what happens to the widget IDs is they get appended to a list that can be accessed in the server. And so here's the code that you've been working with nothing in it, server, function, and then we have 3 arguments. And that first one is the input argument, and the input, and it's a list, and that input list is where all the reactive values get stuffed so that you can access them in the server. Okay? And so to bring this sort of a more specific example here, in our server we can find the text box values with input $mytext. Okay, so input is a list. It's a list that contains the reactive values and actually the real information. So the user typed in hello world, that's stuck onto input as a list, which can be accessed by its unique ID input my text box. So you might think, those of you, everyone in the room is familiar with R, you might think that this would work. And so here I've got my basic page, I've got an ID, and then in the server, I'm just taking that reactive value and I'm printing to the console, or I think I'm printing to the console. But the problem with this is that input is a very special kind of list. Because it has those reactive values, it can't be read by itself by a regular R function. It needs to be accessed basically by a reactive expression. All right, a reactive expression is designed to listen for the reactive value and to react to it. So input is a list of reactive values. Reactive values can only be handled by functions designed to handle them, mostly. There's some exceptions, but and these functions that we're going to talk about are observe, reactive, and then the suite of render functions. So all of these entities in Shiny, observe, reactive, and render, are designed to take in a reactive value, react to it, and do something that you set up. And I'm going to start with the observe and reactive, and in particular, I'm going to start with observe. So observe is a function that's designed to take your reactive value and cause side effects. Now, this is causing side effects on purpose. So, for example, updating another text value, updating a checkbox, that kind of thing. So those are side effects. And it does not return a value. So unlike a traditional R function where you set it up and then at the end you return something, that's not what observe does. And I'll show you what I mean. We're going to go back to that print example that I just showed you, the print example where we had print all by itself, and we're going to make that work by wrapping it in an observe function. So here we are. Exactly the same with one exception. I've wrapped print input my text box in an observe function. Yeah? So is this returning a value? No. This is printing, it's causing a side effect, it's printing to the console. And in this particular instance, because I'm printing to the console, I can't really show you a live example of it exactly, so I'll show you a printout here, basically a screenshot. So on the right here is the code that I just showed you. Here's what pops up. This is a Shiny app, not an interesting one again, but and I say this works fine, and it prints to the console. So observe is designed basically to take in your, to listen for your reactive values, react to them, and not to produce side effects. I mean, to produce side effects, but not to produce any results. And Joe right here, Joe Cheng, he calls an observer eager. And so what happens is we wrap the print statement, right, in observe. Anytime the user makes a change, that observe runs. Any of the code in that observe will get triggered. And so let me show this in action. So I'm going to introduce sort of a little bit out of order a function here called update. All of the widgets that you've seen, so sliders and so on, have an associated update function, and you give it the session as the first argument. And basically all I'm doing here is I'm creating how many widgets? 2. I've got 2 widgets, text 1, text 2, and all I'm doing is typing into one, and then as the user types into one, I'm just going to update the second one. So here I have observe. I'm wrapping my reactive value. Here's my reactive value. I'm wrapping it in observe. And so as the user types, things get updated in an eager way. So let's see that in action here. And I know it's hard to see back there. And what's the delay? How long is the delay? 500 milliseconds. So the user has 500 milliseconds to quickly type, and then it will update. But otherwise, it's perfectly eager. Everything you type in gets responded. Okay, so observe, eager. But observe does not return any results. So it's causing side effects on purpose, doesn't return a value. So let's say instead we want to create an R function, essentially, that returns a subset of a data set or a subset of a list or something like that. We want to return that, and that's where the function called reactive comes in. So this is sort of an alternative to the observe. It operates a lot like a function. In fact, it's essentially a function. It can be called and returns a value. I should say actually reactive is a function. And operates almost identically to a function. It can be called and returns a value. So this is, I'll show you an example, of course. And it's lazy. It's not eager. It will only execute when you actually call it. At the Shiny Developers Conference in January, Joe gave a really great talk on the difference between observe and reactive. and when you would use one and when you would use the other, and the single sort of most important take-home message he wanted to get across was observe causes side effects, and reactive returns a value and does not cause side effects. So here's the haiku that he wrote for you. Can you read that in the back? So setting up a reactive. We're going to create right here a reactive called myResults. And to do that, it's just like an R function. I'm putting it in the server, and now focus on this piece of code right here. It's just like a function. You can imagine that the word function is right here in reactive. And then take a look at what I'm doing. I'm taking in user input. I'll show you the UI in a second. But I'm taking in user input, and the user input is going to be a number. I'm going to take basically that row number, and I'm going to return the species from a well-worn data set in our iris. Okay, and I'm going to show you, here is how you run it. So just like an R function, here's reactive, pretend it says function, and here to actually execute it and return a value, you run it by not just calling myResults by itself, you actually put the parentheses on it, just like you would an R function. And so let me show you how you would use it. So I'm going to give you a blast of code in the next one, but it's going to make use of this code. So here we are. I'm going to run through it. So here's the user input, my row. Unique ID, my row, and I'm going to actually output the result to this text input. So here's my reactive, the one that you just saw in line, the reactive, and I'm taking in this reactive value, right? And then it's going to give me a species. And then within an observe, I'm running that. I'm executing it. I'm executing that reactive, which will give me back species. And I'm betting that half and half of you are completely confused, and hopefully the exercises will help you work through it, because this is new kind of concept in R, I think, the reactive value. So here, I'm setting up a reactive. It's essentially a function, and I'm running that function within observe there. I'm executing it, and I'm causing a side effect within observe. Do I have questions with this? I know it's challenging.
I'm wondering why there's a distinction
Why there's a distinction between observe and reactive, you mean?
Right. Like, wouldn't one type of function be enough if without the
Well, you actually gave, you can answer, okay, sure. All right, go ahead.
Well, please, be my guest.
Well, I should have put the table that you had at the Shiny Dev conference where you actually showed like there's also some additional distinctions that I haven't talked about being cached or not cached, but we'll let Joe answer.
Yeah, the way to think of it is reactives are calculations and observers are actions, and you certainly can. We could have built Shiny with just one construct to represent both, but the advantage of separating out those two is that one of the goals of Shiny is when you make a change, somewhere in the UI, we want to execute the minimum amount of code possible to get your outputs to show the correct results. And one of the ways we do that is by knowing which calculations do not need to be run right now. Okay, and one of the easiest ways to make a calculation that was otherwise be needed to run, not run, is for example, if you are running some kind of prediction, but that prediction is only displayed on a tab that's not currently being shown. Shiny can infer, well, this calculation doesn't need to be run right now because nothing that wants its value is currently being displayed. And if we had not had that distinction between things that are calculations and things that are actions, then we would have no way to know whether it's safe to skip running a calculation. It might have some side effect that is important to execute. So when Zev talks about something being eager versus lazy, that's really what he's talking about. The things that are lazy, those reactives, those calculations, the fact that they are lazy means that we are going to try very hard not to execute them unless it's required for correctness. So hopefully that answers your question.
The good fortune of having Joe as the TA. Other questions? All right. And so let's take a look at this. So we've got a numeric input, we've got a text. Oh, yeah, sorry.
Relationship between the numeric input line and the text input line. They're
Right.
connected, right?
Right, they're connected.
It's
So
not obvious.
let me show you the app and then come back to the code. So I'm going to show you the app. So here I'm typing. Did I turn? Oh, did I turn it on? So as I type row number, it's changing the species number. All right, so they're linked in the sense that as soon as the user makes a change to the input row number, I'm pulling out the row number, it changes the species in the text box. So let me go back to the code. And here it is. So anytime a user interacts with the numeric input, so the numeric input, what's the unique ID? My row, right? So my row, anytime it interacts with my row, that reactive value is right here. And so when my row changes, when the user interacts with my row, it runs my results right here. And what does my results produce? What does it throw out? It throws out just the species. So they're linked in the sense that the user puts a change to the row, and that triggers my results, which is a reactive, to run. And the update function here is used to update this text input. You'll get practice. You'll get practice. Yeah. Yeah, you wanted to, you probably can answer that one better than me.
Sure. So this server function is going to run one time every time a new person connects, or each time you open a new tab or something like that. So that session is a way for these functions like update, text, input to have a conduit over which to talk back to your browser. It is a little bit inconsistent in that some older functions like update, text, input take a session, and then other things that you would think you need to talk to the browser and should take a session, you don't have to pass it a session. We figured out ways later in Chinese life to not require that to be explicitly passed. So whenever you see that, though, just know that that means that something's happening back to the browser.
With Joe here, you also hear the sausage being made, right? Yeah, there was another question.
But the sessions will allow the Shiny app to be multimedia. So looking at different people logging in and they're getting their own results. That's right.
All right, so this, going back to here, I've already interacted with that. So eager, observe, and whoops, I gotta give it a row number. And it gives a species. So the difference between observe and reactive. Observe causes side effects, reactive produces results. And I want to make one more point about observe and reactive. And I'm going to use an example bit of code. So the question for you is, we've got two checkboxes here. Check 1, check 2. Which checkbox is going to trigger the code in observe to run? Yeah. Whichever the user changes, right? And sometimes that's desired behavior. And very often that's not desired behavior. And so Joe built into Shiny a couple of functions that sort of are similar to observe and reactive, but allow you to specify which of the reactive values you want to trigger this code. And I'm going to show you them here. So observe event is sort of similar, is almost identical to observe, and I'll show you. And event reactive is the reactive equivalent. So let's see that rewritten. So this is that same code rewritten. Here's checkbox check 1 and 2, exactly the same as before. And instead of observing observe here, I'm using observe event. And I'm doing that because in this particular example, I'm saying I only want to trigger this code to run when the user makes a change to checkbox 1. Otherwise, if the user changes checkbox 2, don't do anything. But which of this code runs when the user changes checkbox 1? All of the code. So as soon as the user makes a change to checkbox 1, it's going to print the results of, or what's in input checkbox 1 and 2. So basically you're just telling it, you're telling Shiny, I only want to trigger the code to run when this particular reactive gets changed. And that's a really useful alternative to observe, and then event reactive is the alternative for reactive. All right, so we're going to do just a few more questions. This is 8 through 11 in exercise 2.
just a handy tip for you guys. I noticed a lot of people, selecting a block of code, running it, and then changing it, and then reselecting it and running it. There's a shortcut in RStudio that's either Control-Shift-P or Command-Shift-P that will run the same block that it previously ran. So you just change it, and then Command-Shift-P will let you do that as well.
If you're truly stuck, make use of the solution. We don't have that much time, and it definitely will help you get a handle on what we're doing and making sure that we're delivering that.
this returns the function that is called the value. If I think about this value, no, never.
All right, I'm going to give you one more minute to finish up. And like I said, you have access to this this instance of RStudio with all your materials.
Not yet.
Yeah, you'll have access to your version of the RStudio server for another couple days. So you could go through it yourself. And if you need access to this package, I'll try and make it available. Even though a lot of people are, feel free to email me. I know that you're probably too polite to do that or something, but no problem. I'll send you what you need.
Now, when I come here, I would see actually
So it's really important to know that valve reactive is a number very different to say valve is a valve. The latter is a valve is not a so you think of them as kind of like take that valve and assign it to valve. Do it once and that's it. Like valve would never do it. What this is doing instead is saying give this expression input zone plus 10 and give that 10 something called a reactive expression. Okay, right. And that reactive expression, when you access it, will not only give you the value access to the L plus lens, it will not only give you the value map, it will also be sure to notify you.
So, yeah,
That's all. If you want to read the value of valve, okay, that's cool. So, I'll go well, no, it's not defined in the rule environment, it's defined in this function environment. It's defined in offset. Yeah. But if you actually want to see it, you can pass multiple. Yeah. not clear what I'm saying.
All right, why don't we get started with the last bit I want to show you about Shiny Server. Let's talk about time a little bit. So we have an hour and 10 minutes, and I'm not quite sure how long this last bit will last, but not too long. And then I have one more section which hopefully will be like a little bit more fun and less intense code, and probably will go quickly. In fact, we can make it go as quickly as we want. And I will see how things go about whether or not I can give you guys a 10-minute break, but I think I can at some point in that. How many people absolutely need a 10-minute break? Okay. All right. I want to show it later, but I want you to remind me at the end of this. Okay. So let's talk about generating dynamic output. And I mean a little bit different from what I've shown you so far. So we've mostly stuck with it with the widgets so far. So you have the user making an interaction with a widget, and then I'm taking advantage of that update function that's pre-installed in Shiny and makes it really easy for me to show you input and output. But it's not actually writing to the web page in the same way that you're going to want with a plot or a table or even text. And I've gotten that question a couple of times. Why don't I just throw the text onto the page instead of throwing it into another widget? And I'm going to explain that here. And the main answer is that it's a little bit more challenging. There's a little bit more to it. And so I wanted to cover that in a separate independent section with a little more care. And I'm going to start by setting up an application that does not have a dynamic output yet. I'm just going to show you a very simple application that we're going to add to. And here it is. So how many widgets do we have in this app right there? No, we have one, right? So here, unlike the previous examples, we only have one widget. So the user makes a change to that widget. We can't update another widget because we only have one widget. So here it is. And then I say, you type in it, a text box, and then it says you typed. And we're going to spit out text. I'm going to show you how to spit out text in this particular example. So let's take a look at that app. Here it is. I'm going to type in here. It does nothing. Okay. So the server does nothing yet. We want dynamic text tables and plots. And in order to do that, you need two pieces that tag team between the server and the user interface. Okay. And so the first that you need is a render function. And the render function is like reactive and observe in the sense that it can read and deal with reactive values, but a little bit different in the sense that it will output whatever type of output you want, and depending on the name of the function. So in this particular example, render text, it outputs text that the UI can consume. Then there's a render plot, a render table, a render data table, and so on. So those are in the server. It tag teams with the user interface with a corresponding function. So in this case, I'm out of the server, I'm sending out text. And so in the UI, I need a function that consumes the result, and that's an output function. In this case, text output, but there's also plot output, table output, and so on. So, two pieces. Here's one piece. We're going to do text to start. Again, a boring example. We'll get a little more interesting as we go. This is added to the server. So pretend you're seeing a server around it. Here's the render function. In this case, render text because we're dealing with text. And what are we sending out? We're just basically, in this case, sending out the results that the user types in. A very boring example, but we can do any amount of processing in here. If we want to paste it to something or subset a data set or whatever we want to do, we can do all code all the way down to the bottom if we wanted to within that render text function. But for example purposes, I'm just taking in a reactive value, which render can do, and then I'm just spitting it back out. Now note this piece. That's a big source of confusion. So where am I spitting out the results of my render functions? In this case, I'm spitting it out kind of like input. I'm spitting it out to a list called output. And what's the sort of text going to be named in that output list? User text. So let's see how the user interface will take in or consume the result of this. So this, remember, you're seeing it in the server, and I'll show you the full code in a second. There's the UI. So in the UI, you add this line. And it basically takes user text and puts it, and it takes advantage of it and throws it out into your user interface. And note, it's a little bit different from input, of course. We don't have output $user text. Instead, we have the ID in quotes. All right, so it's a little different. Makes it a little bit confusing in my opinion, but we have a tag team, render in the server, output function in the UI. So let's look at that code all together. Here's our render text piece. Here's our text output piece. I'm attaching the results of my render text to a list called output, and I'm accessing it using an output function and the name of that particular output. And then it looks like this. Right? So the tag team, render function, and then an output function. How about a dynamic table? Sounds like we're going to get much more complex, but actually it's just as easy as the text. We have a render table or a render data table. The only difference is render table is sort of a static table. That's not as nice. Well, it depends on your preference, but in this case, a data table is a little bit more interactive, so I'll show you that. Render, and then what would, imagine, you don't have to say it out loud, but imagine what the corresponding function in the user interface would be. Data table output. So render to output. And let's see that here. We've got render data table. Inside, I'm going to do a tiny, tiny bit of processing. The user gives me a number. I'm going to subset the famous cars data set, and then I'm going to output it as a table. And how does it get consumed in the user interface? With an output function, data table output. And a note, I named it new table, so I'm accessing it using new table. And 5, 6, 7, 8, 9. All right. So render to output. Now how about ggplot? Again, it seems like it would be challenging, but actually including a ggplot is equally easy to including a table. So again, render and an output, and in this case, render plot, plot output. Oops. And here's render plot. Here's my ggplot. Here's my plot right here. I named it my plot. It's getting consumed by the user interface and thrown out to the user. And here it is. And I know the text is small. To make the text bigger, as you probably know in ggplot, it's actually a lot of code that I didn't want to show you necessarily, using the theme function and so on. So you can just see the points, for example. Here I'm using jitter, so I'm jittering the points a little bit. Now let's make this particular app based on some things that you already know about Shiny. Let's make this particular app a little bit more interesting. So here we have render plot, plot output, and let's add a couple of widgets to make this. This is technically a Shiny app, but it doesn't do anything fun. You might as well just create a ggplot. So let's make this a little more interesting. I'm going to allow the user, first off, to choose the manufacturer that they want to see in my ggplot. And because manufacturer is a long word, I'm going to change it to make. But basically, I want to use a select input, allow the user to select, make changes to the plot. So here we're going to add a selector. This goes in the UI. Select input. You've seen that already. What's this right here? The user ID, or the input ID, unique. Here's a label. I'm doing something a little different here and allowing the user to select multiple, not just one. So it's not just a classic selector. And then the choices are manufacturer, and then I'm going to select Toyota to start. All right. And now in the server, reactive. And why am I choosing a reactive here instead of an observe? Right. I'm producing output. So I want my app to run MPG2 when the user makes changes. And I'm filtering, basically, using in here. I'm filtering based on manufacturer. And then in my render plot function, instead of MPG, I'm giving it that reactive. And note the parentheses. So when the user makes changes, I want this reactive to run, and I'm putting it right in place of the data. Right, so here's the full code. Here's the select input we talked about. Here's the render plot with my plot. Here's the output. So render to plot output. And then it looks like this. Okay. So far, so good. So let's add one final touch, again, based on material that we've already covered. And that's let's add a checkbox for median sorting. So we haven't actually specifically covered a checkbox, although I've shown you examples. What I want the user to be able to do, in addition to selecting the manufacturer or the make, I want the user to be able to sort that ggplot in order of median, right? It was sort of a jagged ggplot, so I want them to be able to sort that. So I'm going to add a checkbox. Here's my checkbox. Notice the unique ID here, reorder. And I'm setting it to false to start. And then in the server, sorry, it's a jumble here, I know, but here you've already seen this line, MPG, this is within the reactive. I'm saying I want MPG2 first. I want you to filter based on manufacturer. And then if the user clicks on reorder, if it's true, I want you to reorder my factor levels and sort the ggplot based on that. So reorder, if you're familiar with the function, it's a pretty great function for reordering a factor, basically, based on another variable and a function here. And then return, because we're using reactive, we're returning MPG2 here. Okay, so let's take a look at the full plot. It's a lot of code. I know, it's a lot of code, and I even cut off at the bottom here. But a render function associated with a plot output function. And then here we have that final app. And you can select, and then you can sort it by median as needed. Okay. So the final note on Shiny specifically, and then I'm going to talk about HTML widgets after we do a little more exercise, is about the hosting. And a number of you have asked me about hosting. So in everything you're running today, it's being run and shown to you locally, of course. So one option, if you want to share with colleagues, and they know R, is to share the code directly. You can just send them a single page app, or you can send them the UI.R and the server.R, or you can even put it on GitHub or run, and there are functions within Shiny to run a repo on GitHub or run a gist on GitHub. So that's for the technical users. And if you want to share, let's say, with a non-technical user who doesn't know R, you have a couple of alternatives. One is shinyapps.io. It's a nice solution for you if it's a relatively small app with relatively limited numbers of users. 500 hours, I think, per month is for the free tier, and then it goes up from there. But it's public. You can't actually hide it from anyone until you start paying a little bit higher amounts. And then if you're sort of really getting serious with Shiny and you have a company that wants to use Shiny to share between you technical people and less technical people, the Shiny server is a good option. There's an open source one with a little bit less power, a little bit less horsepower, and then there's the pro version that you can host on your own servers and run within your own sort of institution. Do we have questions before we go to this last Shiny exercise? And then I'll remind you, I think the HTML widgets piece is going to be less intense and more interesting. Yeah, go ahead.
So I have a question about Shiny apps. If you have your own package on GitHub, how do you load that for the instance on a Shiny app product?
That's a good question. Can you deploy?
If it is a public GitHub repo, then you just use DevTools to install it.
Okay.
And DevTools will mark it as coming from this GitHub repo, this Git shop, and then when you deploy the Shiny app, that'll all automatically be deployed to the server for you. Yeah.
Okay. But you still use the deploy function on your own machines. Other questions? Yeah, you had a question.
I'm a little bit confused about the concept of the render function. Can you explain the basic mechanism of the differences?
Yeah, I can go through that, and I think hopefully the exercises help bring a little bit more clarity on that. But there are basically three different functions you can use to observe, or let's say, three different functions that you can actually pay attention to interactive values and react to those reactive values. One is observe, one is reactive, and then the others are the render functions that let you sort of put plots and tables and text on. Right? So those three different functions. With observe, you're paying attention. It's an eager responder to your reactive values, and you're causing side effects. So like, well, in this case, we're printing to the console, or you're updating widgets, that kind of thing. With a reactive, it's just like a function. You're returning values. And then with the render functions, you're doing all the processing that you might do in a reactive, but you're actually returning something that the user interface can consume. Anything else?
Just real quick about that. Sometimes people will take things that are actions into kind of observe and stick them into render plot, code chunks just because it's convenient. And it's just important to note that Shiny is going to work pretty hard to not execute those outputs that the rest of do. So again, if an output is on a tab that's not showing, then Shiny is going to assume that the only reason that render plot or whatever needs to execute is because you want a plot. So it knows that the plot's not being shown, but it's not going to execute that code at all. So it is important to keep that distinction between observers being actions that need to be taken for their side effects, and then reactive or calculations. And those outputs really should only be used for actual outputs. That makes sense?
In terms of timing, so it's 12:10 right now. We have 50 more minutes. I'm not going to break for 10 minutes officially, but of course, go do what you need to do because I want to make sure to get through the HTML widgets piece. So let's work on the exercises, take the time that you need to take, finish the exercises you need to on your own time if you don't get through it. Yeah? Okay. Oh, yeah. Let's load it up before I...
I talked to the RStudio Connect guys and they got it working.
Pleased to have
Yeah. Like, okay, I restarted the server.
Maybe I'll start with this. But it's gonna time out on me, right? But it doesn't matter.